Proving similar triangles. Lots going on in this video here. Okay, lots going on. First of all, these opening problems, they're good ones to look at. I'm going to do a little labeling here. 15, BT is 12, TD is 9. Of course, it's skipped. Now, pay attention to the letter pattern. It's easy to get this thing wrong. Okay, so what I do is, I see that, what do I know about the first triangle? Well, the big triangle on the left, triangle BAT. Well, I know TB is 12. Okay, TB is 12. And I don't know, that's the only side I know on that one. Now that 12, that BT is going to correspond to DT on the other one, which is 9. Okay. Now let's see, what else do we know on the other one? We know OT. OT is 15. And OT corresponds to AT. So let's go ahead and find AT. Okay. Cross multiply, 9 times AT equals, what's that, 180. So AT equals 20. And clearly AO is then 5. So you got to pay attention to the letter pattern. Make sure you match things up correctly. Same thing with this next one. This is an easy one to go too fast on. Look, it says triangle ABC. It's going from the top to the left to the right. It's similar to triangle D. Oh, wait a second. DHQ. This one's drawn completely differently. Sometimes people like to redraw it. Put the D up there. I want to go in the same order. That means H would be here. Q would be there. You don't have to do this. But sometimes people really like to do that. Kind of helps them see things. I'm going to cross this out. Now these two things are drawn correctly. Okay, so clearly they match up. So x plus 1 is to 4. Left side is to base, as left side is to base. Sorry, I was just thinking there for a second. So if I cross and solve this, this shouldn't be a big deal. I mean, that's the setup. Now you're doing some quadratics, and you should get an answer of, you'll get 2 answers for x, but one of them is negative, which you have to toss. You should end up getting x is 4, and that'll allow you to figure out that AC is going to end up being 7. Okay, I'm not going to do everything on that one. All right. So kids, down here, these are just the 3 ways we have of proving triangles similar. Angle, angle, that's the most common. Okay. SSS similarity, SAS similarity. These will show up sometimes. They're not as frequent though. Let me show you how to do that. So we're back to some proofs here. Gosh, sorry about that. So this first one here, I'm going to skip step 1 just to save some time. Clearly, we got some perpendicularity there, right? So we have angle C, comma, angle ABE are right angles. If, actually, we can just write def of perp, right? That makes life easier. Def of perp. Then we have angle ABE congruent to angle C. And this would be, of course, if angles right angles, then congruent. We have reflexive angle A, right? This problem's obviously simple. It's very introductory. There's only 2 triangles in the whole figure, so clearly, and they're telling you what to prove. Sometimes when you have multiple triangles in a figure, it might not always be so easy to prove what is similar to what? Okay. This next one here, you know what? This can be done in as few. This can be done. You can 4 or 5 steps. I'm not doing this in the video. I think it's a pretty straightforward proof, but you can check your work with the solution document that I'm going to post. Okay, 4 or 5 steps depending how you do it. This one I am going to do in the video because this one involves something new and a little bit more complex. So you see these dots here. So that's just multiplication. What I would suggest is kind of off to the side. Write down the proportion that this, maybe came from. So you see AB times ED. That means ED would be over here. Okay, these two things. So we have to prove. We're going to have to show this proportion before we can do this, okay? The reason why I suggest writing down this proportion is you can often see which triangles you have to prove then. Now, this one, again, not so hard because there's only 2 triangles in this diagram. So clearly we're going to prove this big one similar to the one on the right. But sometimes it's not so clear. But let's see here. Step 2, we're going to have a little def of perp, right? Angle CED, comma, angle ABC are right angles. Def of perp. Then we can say that, similar to what we did earlier, if angles, right angles, then congruent. We got a little reflexive again. Okay, so we have this reflexive. We had AB, and we had perpendicularity there. So you got to make sure you match up the triangles correctly, just like we've done before. This would be ADB. Similar, if I say ADB, that means I'm going to have to say CDE. Whoops. And that would be by angle, angle. Now, we're going to do something a little, once that these triangles are similar, take a look at this. You see how AB, okay, that's that and that. AB, that matches up to CE, see down here. What else do I know? BD, and that matches up to ED. There we go. Okay, and what we write down here is CSSTP. What does that stand for? Well, if you think for a second, I hope you can figure it out. Corresponding sides of similar triangles are proportional. And then there's just one more step, and that's the conclusion. And there we go. And that reason is just MEPT. And some of you are saying, what? MEPT, remember, is means extremes product theorem. That's just a fancy way of saying cross multiplying. Okay. Is PQT, is this little triangle similar to the big triangle? I hope you said yes. Triangles, whoops. The triangles are similar by SAS similarity because this is 4 to this whole thing is 10. Okay, this is 6 to 15. Well, 4 to 10 is 2 to 5. 6 to 15 is 2 to 5. So those sides are in the same proportion as are these, and then you have this reflexive angle in between. So that's the SAS similarity. This would be a yes as well, because angle QTP is congruent to angle S by CASTC. Oh, what's that? Well, corresponding angles of similar triangles are congruent. So we just said that these triangles were congruent, right? Which means that this angle here must be, sorry, we just said that these triangles were similar, my bad, which means these angles have to be congruent. And if those are congruent, that forces these lines to be parallel because these are corresponding angles. So I've already alluded to these two things here, right? That problem kind of got ahead of it in the previous page. So this is, again, corresponding sides of similar triangles, proportional. This is corresponding angles of similar triangles, congruent. Okay. Now, let's see, I'm going to do a couple of these. Let's look at this first one. So this is where I was saying earlier it can get more complicated, okay? You have multiple triangles here. You have 3 triangles, right? So which triangles are you going to prove similar? Well, we have, let's take a look at this, you see. So JM, well, that's in both triangles. MK, that's only in the triangle on the right, so I'm probably going to have to mess with the triangle on the right. HJ, well, that's in the big one and the one on the left. JK is in, but you see, this tells me something. I'm going to have to use this triangle on the right. And I hope you realize the triangle on the right has this reflexive angle with the big triangle. So I'm guessing I'm going to prove the triangle on the right similar to the big one. So we have a right angle there. We have an altitude. So angle JMK is a right angle. We can write def of altitude now. Say that the right angles are congruent in the next step. I'm not going to write that down. Then reflexive in step 4. And now you got your triangles, right? Just make sure you match them up correctly. Triangle HKJ, similar to JKM. That's by angle, angle, and then you would finish up with CSSTP. Okay. And I'm going to do this one. And again, like what we did before, this one's not so bad. It's a little, because, I suggested write the proportion that this came from. And that's what you're going to have to show first. Okay. This one's not so bad, though, because there's only 2 triangles in this diagram. All right. Only 2 triangles in the diagram. So what we can do here is, we got this parallel. So I'm just going to talk through this one. We can say that this angle is congruent to this angle, and this angle is congruent to this angle from all corresponding angles. Then we can say that these triangles are similar by angle, angle in step 3. Okay. Then, of course, we would say WS is to XS as WZ is to XY by CSSTP. And we would finish again with, whoops, that's XY, XS.WZ, and that's MEPT again, means extremes product theorem. The last proof on the very bottom is just 6 steps. You can try that, and remember, solutions will be on Canvas. All right.